Hey, what's up, guys? It's Nicola from Calcunic, and today we're going to talk about integration by substitution. Let's get right into it. So when we talk U-Substitution, or change a variable as a method to find the integral of some function, we usually want to work with a template that looks like this. And so our function that we're integrating over should have this form. We should have f of g of x times g prime x for some functions f and g. And what we want to do with this is make the substitution and say that u equals g of x. And once we do the substitution, we would get the result, the integral of f of u with the derivative with respect to u. And so this definition might be a little confusing, but don't worry, it's actually quite simple once you see a few examples. So let's say we're asked to find the integral of 3x squared times x cubed minus 1 to the power of 5 dx. And so recall what we have up here. We have f of g of x times g prime x. So our first step is to identify g of x. So we can make that substitution, u. And how to find it is usually look for the function that's a composition. In this case, we have here x cubed minus 1 to the power of 5, which is a composition. And so the innermost part of that composition will be our u. So we say that u is equal to, in this case, x cubed minus 1. Our next step is to take the derivative of both sides. So here we have du is equal to, by the power rule, 3x squared. And here dx, because it's the derivative with respect to x. And notice how in our question we have dx alone. So what we want to do is take this expression that this equation that we've just got and isolate for dx. So we get that dx is equal to, by rearranging, du divided by 3x squared. And so now we're going to make the substitution for u, the u substitution. And so now this is equal to the integral. We'll keep this 3x squared here for now. And on the inside we have u, and that's to the power of 5. And d of x becomes d of u over 3x squared. Notice how 3x squared and 3x squared cancel out very nicely. So we get that this is equal to the integral of u to the 5th and du. And now using the power rule, we get that this is equal to u to the 6th over 6 plus some constant c, because this is an indefinite integral, so we can't forget our plus c. And our last step is to take our substitution, our u, in this case x cubed minus 1, and replace it for u in our last expression. So we have that this is equal to x cubed minus 1 to the power of 6 over 6 plus some constant c. So let's move on to a slightly harder problem this time. Here we're asked to find the integral of 3x over the square root of 1 minus x squared. So once again, our first step is to find u. We look for an element of the big function that has a composition, and in this case it's right here, the square root of 1 minus x squared. And so our u is going to be the inside of that square root. So we have u is equal to minus x squared. And in this case, the derivative gives us du is equal to minus 2x dx. And of course, this means that dx is equal to minus du over 2x. So if we put this all together and make the substitution, we get the integral of 3x over and square root of u. And d of x is equal to minus du over 2x. Now we could go ahead and notice here that the x's will cancel out, leaving us with the integral of negative 3/2 times u to the power of negative 1/2, right? Because the square root of u is equal to u to the 1/2, and because it's in the bottom of the fraction, it's negative, so u to the negative 1/2. And of course du. And now by the power rule, we get that this is equal to negative 3 over 2 times 2 u to the 1/2 plus c, because it's an indefinite integral. And if we return our substitution, u equals 1 minus x squared, and notice that the 2's here cancel out, we're left with negative 3 times 1 minus x squared to the power of 1/2 plus c, or this is just negative 3 times the square root of 1 minus x squared plus c for some constant c. Okay, so we're going to move on to another problem, and this one will be a little trickier than the previous two, and you'll see why in a second. But first, let's find our u value. So we have u is equal to, well, in this case, we're looking for the composite function part of this, and here we have the square root of 2x minus 7. So the interior part of that, 2x minus 7, will be our u value, our presumed u value. And so taking the derivative of both sides, we get du is equal to 2 dx. And rearranging, we get that dx is equal to du over 2. And so now we're going to substitute this back into our initial equation. We get the integral of 2x times the square root of now just u, and dx becomes du over 2. And clearly we have our 2's cancel out, and all we're left with is the integral of x times root u and du. And so we see here that although we did simplify it quite a bit, we still have a x term here, which we cannot have when we're doing u substitution. So how do we get rid of this? Well, we could notice here we have u equals 2x minus 7. And there's a clever way to rewrite this. If we rearrange, we get u plus 7 is equal to 2x. And so therefore x is equal to u plus 7 all over 2. And we're going to make this substitution now back into our equation. We have that this is equal to the integral of u plus 7 over 2 instead of x. And we're going to write the square root of u as u to the power of 1/2. And you'll see why in a second. And so now what we're going to do is simplify this expression. We're going to do u to the power of 1/2 times u and u times to the power of 1/2 times 7. And this is going to give us the integral of u to the power of 3 over 2 plus 7 over 2 times u to the power of 1/2, all with du. And using the rules of integration, we could simplify this. We could separate this and get the integral of u to the power of 3 over 2 all over 2 du plus integral of 7 halves u to the power of 1/2 du. And once again, that's just by the basic rules of integrals. And now that we've reached this step, we can simplify and get rid of the integrals. And so now using the power rule, we have 1/2 from before the constant, and u to the power of 3 over 2, well, that becomes 2 over 5 by the power rule again, times u to the power of 5 over 2. And that's plus some constant, we'll call it c1 in this case. And the other part becomes 7 over 2 times, and by the power rule, u to the power of 1/2 becomes 2 over 3 times u to the power of 3 over 2. And once again, that's plus some constant. Well, in this case, we'll call it c2. And so what we're going to do here is do some simplifications. We have the 2's cancel out here, and the 2's cancel out here. That's going to leave us with 1/5 u to the power of 5 over 2. And over here we have plus 7 over 3 times u to the power of 3 over 2. And we have plus c1 plus c2. And notice that these two constants are arbitrary. They could be anything. And so therefore, their sum could be anything. It's arbitrary. So we could just group them together and call them one constant, c. And our last step is to take our initial expression, u equals 2x minus 7, and substitute that in. For u here, we get that this is equal to 1 over 5 times 2x minus 7 to the power of 5 over 2 plus 7/3 times 2x minus 7 to the power of 3 over 2 and plus c. All right, so let's try some examples with trigonometry. And so right away, our u value is pretty easy to see. It's the inside of the cosine function. So we'll have that u is equal to 3x minus 7. And we have that the derivative of u is equal to just 3 dx. And so therefore dx is equal to du over 3. And if we put this back into our initial equation with the substitution, we get that this is equal to the integral of cosine of u. And we have du over 3. And what we can do here is just simply take the constant 1 over 3 and bring it outside of the integral and write it as 1/3 times the integral of cosine of u du. From here on, it's pretty straightforward. The antiderivative of cosine is simply sine, so this is equal to 1/3 times sine of u plus some constant c, and all that's left is to take our u, 3x minus 7, and replace it back into the expression. We have 1/3 sine of 3x minus 7 plus c, some constant. So we're going to continue with a slightly more complex question. We have the integral of sine x times cosine cubed x. And right away we see that our u value is going to be cosine x because that's where our composite function is. We have cosine x and then we're taking the third power of that. So u is equal to cosine x, the interior part of that composite function. And so now taking the derivative of both sides, we have du is equal to the derivative of cosine. That's negative sine x dx, and by rearranging we get dx is equal to du over sine x, and that's negative because we have negative sine x dx over there. And so now we're going to put this back into our equation using the substitution, and right off the bat we can notice that we have sine x here in the denominator, and we have a sine x here, so they are going to cancel out. And that's going to leave us with the integral of u cubed, because u is equal to cosine x, and negative du. And so this is going to be equal to, just moving the negative sign out of there, the integral of u cubed du. Now to find this antiderivative, we're going to take the power rule of u to the power of 3, giving us u to the power of 4 over 4. And that's plus some constant c. And finally, by taking u equals cosine x and plugging this into this equation, we get negative cosine to the power of 4x all over 4 plus some constant c. All right, so we're going to move on to some questions with e in the natural logarithm. Here we have the integral of e to the power of 7x minus 6. And so in this case, the u is pretty easy to find. It's going to be 7x minus 6. And this is because this is the interior part of the composite function e to the power of 7x minus 6. Taking the derivative of both sides, we get du is equal to 7 dx. And by rearranging, we get dx is equal to du over 7. And so now we want to put this back into our initial equation. Now by using substitution, we get that this is equal to the integral of e to the u and du over 7. What we're going to do here is just take the 7 out to the front, 1 over 7. So we have 1 over 7 times the integral of e to the u du. And so e to the u is one of the most easy antiderivatives to remember. It just stays exactly the same, much like the derivative itself. So we have 1 over 7 times e to the u plus some constant c again, because this is an indefinite integral. And our last step is to take our u equals 7x minus 6 and plug it back into the equation. We get that it's equal to 1 over 7 times e to the power of 7x minus 6 plus c for some constant c. So here we have our final question. We're asked to find the integral of cosine of ln of x all over x. And so don't get intimidated by all these functions. Here in the numerator, we have our composite function cosine of ln of x. And so we have our u value is going to be the interior of that, and that's going to be ln of x. So u equals ln of x. The derivative of both sides yields du equals 1 over x. The derivative of ln x, and then dx, and by rearranging we get dx is equal to x du. Now if we substitute this back into our initial equation, we have the integral of cosine of just u now all over x still, and then dx equals x du, so we write x du here. We can see that our x's nicely cancel out. So all we're left with is the integral of cosine u du. Now it's pretty straightforward from here. We know that the antiderivative of cosine is just sine, so this becomes sine u plus c for some constant c, and we want to take our initial value for u, ln x, and plug this back in, leaving us with sine of ln of x plus some constant c, our final answer. Alright guys, thank you so much for watching. If you had any questions about the video or just other video suggestions, drop them down in the comments below. I do try to get to all of them. And if you made it this far, leave a thumbs up if you liked it, and subscribe if you loved it. That's all for me. Until next time.